Welcome back, students. So we are in the 17th part video. In this video, we will learn about a new pattern of problem on polynomials. Till the last video, we saw some 4 patterns. This is going to be a 5th pattern. So as a status check, we have completed the theory part, whatever you are seeing tick mark here. We have completed the board problems for the geometric meaning, and presently we are doing the sample and board problems for the zeros and coefficients of a polynomial. And polynomial division is something which will go towards the end. So if you landed directly in this video, I would request that you check or view video 7 as well as video 9 for better understanding of this problems in this video. So the fifth pattern. So the question will give you one or both the zeros, and you need to find either the coefficient of x square or x or under constant term. It depends upon the question. So you are given the zeros, but you need to find the unknowns, which are the coefficient of x square, x and constant term. So in the example problem, you see there's a quadratic polynomial x square plus bracket a plus 1x plus b. For this polynomial, the zeros are 2 and 3, minus 3, sorry, 2 and minus 3. You require to find out what is the value of a and what is the value of b. Well, let us see how to proceed with this. As I told you in my previous videos, you first need to fit this equation into a standard form, that is ax square plus bx plus c. This problem is this question, whatever is given, is already in the standard form. You have the x square term first, then bx term next, and last you have the coefficient. And whatever they are given is 2 and 3 are zeros of a polynomial. So alpha is 2 and beta is equal to minus 3. The sum of these two, that is the sum of the zeros alpha plus beta, is minus 1, that is 2 plus minus 3, and product of the zeros alpha beta is 2 into minus 3 is minus 6. So from the polynomial you can find out the product of the polynomial, that is the formula is constant term divided by the coefficient of x square, which is b. Now you will be equating this b to the product of the polynomial, whatever we got. So b is equal to minus 6. So you have found out one of the term, b is equal to minus 6. You have an answer for one of the unknowns. So second unknown, you will be now trying to find out the sum. Similarly, the sum is, you have to use the formula minus of coefficient of x divided by coefficient of x squared, which is minus a plus 1 is equal to the minus 1 whatever you saw here. So solving this both, you get the value of a to be 0. So this completes our problem. We will see another example, but before that, there's a small caution here. See, in this problem, you see there is a given here and a b given here. Do not confuse that a and b with the standard equation form a plus bx plus c. Ideally, they should not have given this a and b in this context here because it is confusing. I thought I will give a different alphabet, but tomorrow in case you get a problem like this, you should not get confused. So I retain the same fashion. So a and b in the context of this question are two unknowns which you are need to find out. So when you have difficulty to use the formula, whether it is sum of the zeros is minus b by a and the product is c by a, you have a confusion between the ABC used in the formula as well as the unknown ABC. That's where this format of the formula comes into your rescue. A constant term divided by coefficient of x square, that is the product. So that formula you have to apply and solve the problem. So going to the second example, they have given one of the zero of the quadratic polynomial as 2. So, and the quadratic polynomial is kx square plus 3x plus k, and you need to find the value of k. And 4 options have been given. So the solution approach will be, they have given that 2 is a zero of the polynomial, which means when I substitute this 2 in this polynomial, the value will be 0. So what I'm going to do is I'm going to find out the value of p of 2 and equate that to 0. So p of 2 is equal to, I'm substituting the value of 2 here and here, that is k into 2 square plus 3 into 2 plus k, that is exactly what you find here, that you are going to equate it as 0, upon which you find out the value, resultant value is 4k plus 6 plus k is equal to 0. You solve this linear equation. This is a linear equation which you solve it where when you put the 6 on the other side, it becomes minus 6, and the 5 you bring it down and becomes k is equal to minus 6 by 5, which is your option D. So now we'll see a third example. This is also somewhat similar, like they have given 3 as one of the 0 of a polynomial, and here you need to find out the value of the constant term. You have to find the value of constant term a here. So you are going to follow the same format whatever you did in the previous problem. You are going to substitute the value of the 3 in this value of x. Since 3 is a 0 of the polynomial, the resultant solution will be 0. Hence, you will be relating or equating this to 0. So 2 into 3 square plus 3 into 3 minus 9a. What are you finding here? That I'm equating to 0. And I'm solving this equation to get the value of a as 3. So the value of a which you need to find out is 3. So now let us move to the fourth example. Now it is slightly different here. Here they have given you two zeros of the polynomial. 1 and 2 they have given two zeros of the polynomial, and you need to find out two constants or two unknowns. You have k and m which you need to find out. So this also has a similar pattern when compared to our earlier problem. The only difference, you have now two values to be equated to 0. P of 1 equate to 0 and P of 2 also to be equated to 0. So first, P of 1, I substitute the value of 1 in the place of x. 2 into 1 square minus k into 1 plus 2m. So that is what I have put here. And that leads to 2 minus k plus 2m is equal to 0, which on rearranging becomes k is equal to 2m plus 2. This is one equation. Now you have to repeat this with the other 0, 2. You have another 0 which is 2. You have to repeat the same substitution, and when you substitute value of 2 in the polynomial, you get 8 minus 2k plus 2m is equal to 0. This is the second equation. You now have a pair of linear equation which needs to be solved. What I'm going to do is, in the earlier equation I had value of k is equal to 2m plus 2, which I'm going to substitute in this value of k. That's what I have done here. 8 minus 2m plus 2 plus 2m is equal to 0. Now it is easy to resolve, and on resolving I find the value of m to be 2. This m you can substitute in any one of the equations. You can either substitute in 1 or you can substitute it in 2 and still find the value of k. So I am going to substitute the value of m is equal to 2 in this equation, 2m plus 2, and find out the value of k as 6. So we have seen 4 example problems. So in our next video, I'll catch up with a much more exciting or a different kind of problem which is slightly tricky and more probability of appearing in board exams. So till then, bye. Thank you.